Excellent. Well, thank you everyone for being here. Very excited to share what social housing is doing in terms of energy performance in its portfolio, which is directly related to the window manufacturers. So I'm hoping to very much prime the industry for what we hope is going to be a large amount of high performance buildings coming in the near future. Oh.
No, it was me. Sorry. Okay, try again.
All right, and we're going down.
There you go.
Perfect. So my goals today are to let everybody here know that the social housing providers in Ontario have secured over $1.5 billion for high performance buildings. And that money is being looked to be spent in the next 5 years until 2028. Now, this is not actual news. This has actually been announced, but you probably didn't notice it because one, you didn't see it aggregated as one big fat number for all of Ontario. And also it was probably done with a minister of some kind standing in front of a booth, and it probably got lost in the noise. But this money has been secured. And the second point of the reason I'm here is me and Terry were talking, and we have general concerns that the industry may not quite be ready to deliver on that level of performance that we need for these windows in that short time frame. So we got together and he said, you just need to come and talk about this as much as possible so we can make sure that the fantastic Canadian and Ontario manufacturers can take advantage of this opportunity, and so that we don't have to go overseas for the products. So today I hope to show you what we're doing and then go through how the Ontario and Canadian manufacturing industry can get a piece of that business in terms of the windows that we need, the performances that we're talking about, and the funding that we've secured. And with me online is Sean Botham. So I'm Dan Zikar. I'm from Ottawa Community Housing. And we have Sean Botham from City Housing Hamilton. Can you hear us, Sean?
Sure can, yeah. Thanks, Dan.
There we go. Perfect. So you'll be the voice of God every once in a while. So I'm going to start by taking you through the retrofit scenario that is taking place in Ontario. And then I'm going to kick it over to Sean to talk about the new development side, all of which need a high performance building, are being built to high performance standards and therefore require high performance windows. So a little bit of a background. So Ottawa Community Housing, we are Ottawa's largest landlord, Ontario's second largest landlord, with about 15,000 units of social housing. We've got basically every kind of housing product you can imagine, but about out of 160 communities, 100 of them are a high-rise product, and about 60 of them are in a town home like complex with maybe like 200 units or something like that. The most important thing, over 2/3 of our portfolio are over 50 years old. In fact, we've got stuff pushing 60. And so you can imagine that we're actually at this life cycle tipping point, which is one of the impetuses to get these deep energy retrofits done. And we consume a considerable amount of utilities. I always like to show we're somewhere in that $23 to $25 million range. For the past 10 years, we are a significant utility consumer, and we are looking to reduce that energy consumption. And historically speaking, this is how we've been doing it. It was kind of the low-hanging fruit, if you will. I love showing this picture. This is a picture of one of our project managers standing on top of 3,000 toilet seats. We've done several portfolio-wide retrofits, including water retrofits, so the toilets that you see there, LED lighting retrofits, all that kind of stuff. And that's how over the past 10 years, we've been able to save about $46 million in total. In the same time, we've also added a significant amount of solar generation to our portfolio, over 500 kilowatts currently operating. In fact, last week, that became 620 kilowatts. And by 2024 is going to be a full megawatt of urban solar generation. So this is how we've been tackling the issue historically speaking, but now we're coming into a very, very different reality, at least in Ottawa, as well as the rest of Canada. If we're trying to meet the IPCC targets, if we're trying to align ourselves with the climate change targets, it looks something like this. So this is a graph for Ottawa, but it looks very similar across Canada, which is this is our pathway in terms of reaching the net zero targets that are, whether it's 2040, 2050, we can split hairs on that. But basically, we need to decarbonize these 5 major activities in Ottawa: electricity, transportation, waste, and then we fall into the existing buildings. About 1/3 of the emissions for Ottawa need to be tackled through retrofits of existing buildings, as well as the new buildings that we have down there at about 8%. So a significant amount of Ottawa's GHG emissions and the rest of Canada, in all honesty, are going to be tackled through the existing buildings and the new buildings that we're building right now. And it's going to be done with high performance components like can be manufactured by the fine people here. So how are we tackling that issue? So I'm going to show you how OCH, a pilot project that OCH took in order to do a deep energy retrofit as kind of a proof of concept of the system. So we went to 197 to 203 Pressland, the prefabricated exterior energy retrofit project. It is a 4-unit block of townhomes, 3 bedrooms each, 2 stories, built in the 1960s, and had about $7,200 of utilities every single year, right? And it was emitting about 18 tons of CO2 every year. After we did our deep energy retrofit, still 4 units, 3 bedrooms each, renewed in 2020, and it is now fully net zero energy, and it is emitting 0 tons of CO2. And we did all of that retrofit with the tenants in place. So just to give you a little bit of stats, and then I'm actually going to show you a time lapse of what we did. So, I mean, we're significantly improving the building envelope by improving, going to 30s and R30s, 40s and 60s in the roof. We're replacing the existing natural gas equipment with heat pump technology, both on the domestic hot water as well as the furnace. And obviously, once we've done that, we are adding solar on the roof to try and generate as much energy as we're going to be consuming. Just an idea of how the area is measured up. So we significantly reduce the space heating requirements, significantly reduce the domestic hot water. The plug loads, the lighting, the appliances stayed fairly similar. Space cooling was added to this building as a result. So now we've got a heat pump. We're able to provide cooling in spaces where before they only had heating, which was a great benefit. And obviously there wasn't any generation before. So now we find ourselves in a net energy balance that is basically net zero for this site. And we've now got our first year of monitoring on this. So here, this is how much the pre-retrofit building was consuming, about 120,000 equivalent kilowatt hours every year. The post-retrofit building looked something like this, just over 40,000 kilowatts that it consumed each year. And our so a 66% reduction in terms of the energy consumption of that building. And our generation lining up with that, basically just lining up pretty much exactly with the amount that we're consuming. So we've got ourselves our first net zero building, basically missing it by equivalent of something like 0.01 of a difference, right? So basically it is done, it can be done, and it was done by a small housing provider instead of some big company, right? So what we're going to do now is I'm going to show you in real time in a 2-minute time lapse what we did. So Terry, can we switch over to the other video?
Let me see here.
Quick sip.
Come on. I'm getting there. Just be patient.
No worries. I speak really fast during this, so it's good to rest a little.
Okay.
Oh, you want to launch?
Okay, let's go.
Press play. All right, what we have here is our Pressland building. We dug down to the foundation, basically replacing the old weeping tile, but that also exposed the foundation, gives us an opportunity to waterproof and put an air barrier across the entire foundation. And then we backfilled with 8 inches of EPS against the foundation and brought that all the way above the foundation. Now you see us, we are coring some holes along the brick. So we put in some brackets that are going to support a beam that is going to go all the way around the entire perimeter. Then in our shop offsite, we're stitching together SIPS panels, basically producing these 9 by 20 foot super panels that make up the entire facade of the building, with the windows and the doors already cut out. So the SIPS panels are 8 inches of EPS, and then we're basically covering them with that air barrier that we're going to tie back to below grade, but we're trying to finish them as much as possible, putting the strapping as well as the siding on it, and literally trying to deliver an fairly finished panel directly to site. So that was our staff assembling it, and it's our staff manipulating those panels and actually installing them. So this is them being delivered to the site, and now you're going to see us putting them on top of the building. We put about 8 panels up every single day. So it is designed to be an extremely quick process, similar to the energy sprong model that we've heard coming out of the Netherlands. So now that we've got this new building envelope, we can we can get rid of the natural gas system, put in the heat pump hot water tank and heat pump furnace. And in order to finish the roof, so we brought that AVB from below grade all the way through the panels, and then over the roof, we basically put spray foam over the existing roof and put an extra super roof on top to accommodate for the extra insulation we needed. That also gave us a perfect southern exposure to install 34.8 kilowatts of solar panels. So overall, the new building envelope that we've installed has reduced the energy consumption of that building. The new efficient mechanical system that we've installed inside delivers the energy that's required as efficiently as possible. And the solar panels are able to generate as much energy as this building will consume, giving us our 0 rating on the NR Guide system. Now, so that's very fun and impressive. So now can we jump back to the presentation? There we go. I've given that talk a few times. But we're here at a window manufacturer. We're here with Fenestration Canada. And what is the one thing that we did not see, unfortunately, in that beautiful time lapse?
Hang on. I'll get there. Screen. I think it's
There's your, yeah.
All right.
Right back in.
okay. So let me go back from current slide, right?
Current slide. That's right. So what unfortunately was not featured in those videos, it was unfortunately the windows, because if I can be terribly honest with you, it was one of the parts that we had the most trouble figuring out in terms of, hey, what performance do we need to get? And sourcing these windows, especially, unfortunately, we had to do this entire project during COVID. So I agree, there's some added supply chain issues that came about, but these windows are also extremely heavy. There was discussions in terms of with the architects, the manufacturers, and in the installers, how are we actually going to create this seal that we're trying to keep that continuous air barrier? How are these very heavy windows going to be installed? How basically, I mean, we can come up with a very long list, but this was one of the weaker parts of our project. And that's, I mean, as I was discussing with Terry, he's like, that doesn't necessarily surprise me because maybe this is not as much on our radar. So my goal here today is to put it on the industry's radar because we've done this one. We need, oh, wait, I'm going back up. That's the wrong way. We need to do a lot more of this. So if I look specifically at this 197 Pressland project, we were talking about getting performance for these windows somewhere around 1 U value, right? For what we installed, that's what we ended up going with. But this was one building, 4 units, right? We're now looking to take that exact model and expand it across our portfolio. So what you're looking at here are the current projects that we have in design to expand that similar deep energy retrofit, where we're trying to reduce the building's energy consumption by at least 60%, if not more. And the numbers that we're talking about, so that first one, Britannia Woods, that big, oh yeah, let's do this. So this big complex here, that's 180 units that need to get that treatment and reduce their energy consumption by 60%. That's about 1,000 windows because each one of these units has 8 windows in all of them. We've got King Edward, which is this building up top here. 40 units need to do the same thing. 115 units at 215 Wergenbergs, that's here. We've got 255 Don, we've got Walkley Manor. We are currently receiving concept designs from our architects and working with them to come up with a solution to do that deep energy retrofit. And some of the numbers that they're telling us is, hey, we're We need these 1 U-value windows. We need these 0.7, maybe we need even 0.6 in order to reach the targets that we're setting out. And this is just Ottawa. So if I sum up, I wanted to highlight that. The quantities that just Ottawa is looking at over until 2028 for just its retrofit is we've got about 2,400 units worth of deep energy retrofit to do. And that's going to be somewhere around 10,000 windows. And that's in the next 5 years. And these are the performances that we're looking at. But Ottawa is not the only ones who are looking at these types of projects. We've also got, so you'll hear from Sean from Hamilton. So up here, we've got the Ken Sobel project in Hamilton, which is a huge high rise. It's the largest NRFit retrofit in the world that Hamilton achieved. And Sean will be speaking to that. But that is an example where we needed some very high performing windows in order to reach those targets. We've also got an example here from Windsor, 255 Riverside, where they are trying to do the exact same thing, reduce the overall energy consumption by 60% in the building. And they're going to need high performance building envelope, high performance windows, and new mechanical systems. These are just examples because overall, when you take Ottawa, Toronto, and Windsor, we're looking at over 15,000 units worth of social housing that needs to be retrofitted in the next 5 years. And then, just by the way, if we then look at the National Housing Strategy, where we're getting the funding for these things, they're talking about over 250,000, so 250,000 units that need to get this treatment sometime between now and 2040. So the first part of this pitch is on retrofits. Here is the size of this market right here in Ontario, right here in Canada. And that is why I think that we should be talking about this. And now I will very gladly kick it over to our friend in the sky, Sean, who will give you a little bit of context in terms of the new development volumes that are coming down the pipeline for Hamilton, Ottawa, as well as some of the other housing providers. There's Mr. Sean.
Hey, everyone. So I won't talk as fast as Dan. I'm a little unwell and stuck here in Hamilton. So sad I'm not joining you right now, but really excited to present to you some of the new development work that we have underway in Hamilton, and want to just provide this as context for what other publicly owned or municipally owned, sometimes regionally owned housing providers across Canada are doing. So it truly is amazing, and it's been enabled by federal initiatives. So and there's a lot of glass. There's a lot of glass involved. So in terms of Hamilton, I mean, nationally really, but in the Hamilton context, in yellow here you can see these are the buildings built in the 60s and 70s. In blue, these are our new developments, 9 underway. And I mean the retrofit numbers of units is incredible, but it's also quite significant how much new construction is happening. And really, this is a new era of public housing, and this is construction of deeply affordable, also moderately affordable, and it's being led by nonprofits and municipally owned corps, but also in partnership in many instances with private sector entities as well. So 9 projects in Hamilton. These represent well over 200 million in reinvestment in housing. And what's really notable is these were just the opportunistic, easy to configure projects. We're actually envisioning 10 to 20 more, $1 billion just in Hamilton in new construction. So that's what's in the envisioning stage, never mind the 9 underway already. And I just want to pause on the idea of quality and character of what we're building out. This is a view from one of the retrofit units in our tower, which was our flagship building. Dan mentioned that just kicked off our redevelopment work that we restarted. So you can kind of get a sense from this image, a 60s building brought back to life. It's very high quality. And if we think of the full new construction that we have underway, it's even better quality. So when you think of affordable housing, social housing, public ownership housing, the new era is dramatically different than the original stock that was out there. And the way that we think about it is, this is high-end housing but at affordable prices. So high-end quality, affordable prices. So just that's a bit of the concept. I'll just note on the Ken Sobel 5-room McNabb. This was, as Dan mentioned, the first of this size and kind globally. And what it looked like is 94% GHG reduction and incorporation of accessibility, all these things, and in total energy demand intensity, an 89% reduction. So dramatic reduction that we have with off-the-shelf parts, except for the windows and some of the HVAC. So those are our two real pain points. Then I just want to speak to, the speed and delivery. We all know the development life cycle is quite long. 5 years is pretty typical, and well beyond that is normal as well. But how the federal government is releasing funds, and this happened today. 1.5 billion was released today for rapid delivery projects. That's new money to deliver projects in just under 2 years. So these are some examples of projects we've done in Hamilton that way. So on the left, this is a commercial conversion. So taking underutilized commercial space, converting it. And often these have large glazing areas that need to be redone. At the top there, we have a volumetric modular that will be delivered. It's under construction in factory right now, will be delivered by summer. And in the bottom right, this is a panel for a 10-story panelized high-rise going up. All of these are to high performance standards, require high performance glazing options. And I mentioned earlier, just this idea, there's the concept of partnership with the private sector. And this is one of the ways we fund ourselves, but also fund new development, but also what we're doing is kickstarting an industry. So part of the public sector responsibility is not just, lowest cost over the long haul as the owner and steward of funds, but how do you actually change a market? And so what we've seen with partners we've aligned ourselves with, both nonprofits and private sector, is them actually taking up the high performance banner and providing better thermal comfort, better energy usage for their tenants, whether rental or ownership. So and what that looks like is, in these two developments pictured here, there was 91 units previously at each site. There's now going to be over 1,300 units. And many of these, certainly our buildings, nonprofit partners, and some of the private sector partners are high performance. So the scale is quite large, the spin-off scale as well. And as Dan mentioned, this is across the country. These are actually Ottawa projects, 2 on the left in construction, 2 on the right in planning. These alone, these 4 represent almost 4,000 windows. So the scale, I can't underscore how big the scale is of projects. Windsor, this is under construction right now. It's happening wherever you turn the page to any new city or region, and high performance by the public sector is happening. So this national housing strategy, there is over $72 billion already committed. Today was a 1.5 billion addition to that. So it's even growing the commitment levels. And in terms of new development across Canada, Dan highlighted the 268 existing units being retrofit. This new development work is 110,000 units. These are new units being added, of which we're a part, but every community in Canada is participating in. So it is a massive rollout. And obviously, high performance means different things to different people. In terms of the passive house, whether the EnerFit or the new construction standards, these are very, very efficient windows with all the ways of doing that you can imagine. This is just final slide cut sheet from windows we have installed in a project, giving you a sense of the true high performance that we're after in terms of U values and other ratings with solar thermal heat gain and all these things. So high performance windows, a necessity for our mandate. We will purchase them in Poland. We'll purchase them wherever, but it would be really nice if we could do it in province, in country. That's me.
Beautiful.
Great. Yeah.
Perfect. Thank you so much, Sean. We'll kick back to the other presentation.
I think that's it.
So, and I mean, so as Sean was kind of saying, hey, this is all the, here is the volume. So now one of the questions that's probably in the back of our minds is, well, okay, well, why are we so tied to the high performance? Hey, we've got windows. We can give you some windows right now. So if we go all the way to after his slides. Yeah. Voila. So I'd like to tell you what funding is secured for this and why we need the high performance. So just OCH, that CMHC co-investment fund money, about $240 million for capital until 2028. In order to access that money, which in all honesty, we need for that 60-year-old stock in order to keep it around and in order to do a new life cycle with it, because it's kind of at a life cycle tipping point, we need to achieve 25% energy reduction and 25% GHG reduction of the portfolio that we've submitted. Now, we're not going to be doing a deep energy retrofit in every single building. In fact, we're targeting about 15, so we go really deep there. But that represents, for the portfolio we submitted, which is about 11,000 units, 45 million equivalent kilowatt hours of savings is what we need to deliver in order to access our money. About 7,000 tons of CO2 reduction is what we need in order to access the money that we need. So, and we're not the only ones. If we look at Hamilton, so they've got about $100 million, and that's tied to something like 4,000 tons of CO2 savings. Windsor, just under 60 million, that's tied to about 3,000 tons of CO2 savings, as well as equivalent energy savings. And Toronto estimated some numbers, but it's about $600 million for about 15,000 tons of CO2 that needs to be saved. So the reason that we are so focused on this high performance window that we're talking about, or these high performance pieces of equipment, is because our funding is tied to it. This money has a color and it's very green. And that's only 25% of our existing portfolio. So we've got a lot. Come on, that was good. That's only touching the first 25% of the energy savings in our portfolio. We need a strategy eventually out to 2040 that's going to tackle the other 75%. And just by the way, it's a similar model for the new development. In fact, for new development, we're targeting, they're asking for 55% energy savings over the National Energy Code for buildings. So all of this money that's coming down, all of these announcements include a high performance standard in order for us to even be able to access that money, which is why we want to work with fantastic manufacturers like you so we can get these products and these projects done. So we're kind of here trying to act as a little bit of a catalyst market, because as an opportunity to catalyze the market. So why are we a good choice? Well, we are long-term stewards of public assets. Everybody pays the utility bills on these buildings in a way, and everybody's money is doing these retrofits. And we have a duty. We are not going to be flipping any of these buildings. We're not selling any of these buildings. We're going to be operating them for the next 50 years, the same way that they've been operating by us for the past 60. And so we have a vested interest in making that investment up front that pays dividends over the lifetime of that building and saves us in overall operating costs. So we're looking for that long-term affordability. That's something that's built into our models. We're looking for that resilience, because we know that if we put something cheap in, we then have to rip it out later. We're not actually saving ourselves any money. And in all honesty, we're hoping to have these things produced locally. Because I'm going to give this unfortunate cautionary tale. So 1290 COLDREY was Ottawa Community Housing's first passive house building. This was our first foray into new development, and we wanted to make it passive house. So we ended up having to source the windows for this project from Clearwall. And so we had to import these from Ireland in order to get the performance that we were looking for, right? Like somewhere around that 0.75 of a U value. And that was 120 windows. So this was, I mean, small potatoes, yes. But the trouble is, this is self-defeating because we have a limited budget. We'd like, if that was locally sourced windows, it would be a whole lot cheaper. It'd be stimulating our Ontario or Canadian economy, which would be completely well, how about this? I'm looking forward to lose-lose, because then we import them. We don't get to keep that money in terms of our business stimulation, and it costs a whole lot more. So we're hoping to go down the win-win-win path rather than the lose-lose-lose path, which is why we're here today. So what are going to be the next steps? So in all honesty, these four housing providers were getting together, and we're like, unfortunately, we've all got public procurement processes. We've all got our own separate boards, and all of this money is tied up in different ways. So there's not like, hey, there's not one giant PO that's going to get issued, right? And in all honesty, we also want a competitive marketplace, as you guys do. So the way that we're approaching this is we're actually partnering with Passive House Canada in order to imagine aggregating the specifications of this demand. So we're taking the concept designs that are literally coming in for those projects that I showed you, as well as our new development stuff from across the province, and sharing that with the experts at Passive House Canada, who are going to imagine creating a lowest common denominator of this high performance standard that they can then use to engage the industry and see, hey, who would be interested in making like a pre-qualification, saying, I know I can do this. I could provide a window that looks like, if you stay within these parameters, or for a below 4 stories, I can do this. For an above 4 story, I can do that. And we're looking at this price range for these types of volumes as well. And that way, what we get out of that is that pre-qualification will help our designers put a window in their spec that you guys are going to be able to actually produce, and you guys will know that the volume is coming, and therefore we will have a perfect manufacturing cycle here in Canada for producing high performance windows. Yes, and I believe that takes us to the end. So we would very much welcome many questions. You're still out there, Sean, right?
Sure am. Yep.
Absolutely.
Okay.
So
thanks, Daniel. So over the last number of years, talking to a lot of manufacturers across the country, and I'm not a huge proponent of Passive House. The company I worked for, we developed 3 Passive House systems, but I always heard, Passive House, it's a unique building. There's not really a market. I'm not going to invest all this time and effort to make these products because I'm only going to sell a few. And then somewhere along the way, Daniel and I crossed paths. I don't know where we connected, but he started telling me millions and billions of dollars of investment going into projects that need these products. And I'm sure you were listening. I heard Poland and I heard Ireland. Well, that just burns my britches. Those products need to be coming out of Canada, and we have them now, and we need to develop more. So really happy to have Daniel and Sean here to reinforce that these projects are going on all the time, and they're only growing. There's a lot of money being invested by the government into these projects, and they want that green product, right? So questions?
Yeah, throw them away.
Thanks. This is more of an offer as the Pacific chapter. I would love to invite you out to BC, and you can talk to some of us out there.
Okay.
That this is the rest of the country has people playing the same game we have out here. In BC, we're regulated this way.
Yes.
Like we have essentially gotten beaten into it. But I know a handful of our members in BC would be thrilled to hear this. And what I can hear, there's no amount of work we as manufacturers can do to help you achieve what you're asking for, that I think we might be able to grow to it based on the quantity of high performance companies that I know in the country, but it's going to be tight based on the quantity that you're talking about.
And if I can, something that Terry alluded to, so I know the word Passive House got tossed around a lot. One question that we had when I talked to the Ontario group was, hey, do I need to certify these? And the answer is not necessarily, because here's the thing. This money doesn't require Passive House certification. It doesn't require, what it requires is the performance. So if we're able to, some of the providers decide because it simplifies their specs or things like that, that they're going to go after certification. But only 1 out of 5 of the projects that I was showing you that we've done historically was a Passive House certified project, and we needed Passive House windows. The other ones, we are simply looking for that performance. We don't care what label it has, as long as we can get the energy reductions that allow us to hit those targets. So we doesn't necessarily need to be Passive House certified. We can get that performance in different ways. I assume that we're going to, what I hope we have is at least a half dozen manufacturers that are interested and say, okay, hey, my setup does 0.9 and I give you this really great solar heat gain coefficient. Hey, I dove down and I can give you that 0.65. Yes, it's more expensive, but this is the part that I'm going to tackle the high rise ones, and I'm going to give you is good. I can get you 0.9 up there for the ones that need really good reinforcements, but down below, hey, I can go down to that 8 or that 7, and we can do that. So. Yep. Yes. Perfect. Thomas?
Yeah, I just want to say hi to Sean in person, well, virtually. So Sean, and same thing for Dan. One of the challenges, and I've worked with governments, is the procurement process, or the how to become a preferred provider, or whatever you want to call it. It's usually very complicated, takes a lot of time and energy. I know as a government worker, it might not seem it, but for industry, it is very arduous, and a lot of people just give up. Same thing for projects. I mean, I've worked with ST for installer programs, and it took almost a year and a half just to get all the dots crossed. And we had an expert from ST help us to get funding from the government to finally start a program. So not everyone is willing to spend that amount of time to get there. So and we're not talking about like 100,000 windows. We're talking about maybe 5,000 windows for low rises for the beginning. I'm not talking about high rises, because for high rises, you're looking at a commercial provider. But if you're looking for residential, for townhomes, that's the other thing too, is the portfolios. You're going to have to separate what are townhouses compared to high rises, because it's two different games. And it's not, well, there might be some companies that can do it all, but it's not every company that can.
And that's exactly right. Like we don't imagine there's going to be one silver bullet. And that's why we need to engage the broad industry to figure out, because we need solutions for every level. And 100% like that procurement. And I know that hopefully what I showed you on screen doesn't sound too onerous, but it is really to help us bypass some of those. Because imagine we get to the other end with some of the, half dozen manufacturers that are interested in providing an answer to those pre-quals. Then that's the thing that our architects are going to be putting into their specs. That's the things where we can go, hey, we want a manufacturer and installer, because the installation is just as important as the product, and we're having trouble, and they're sending us carpenters. So we're actually going to bundle for these next 5 projects. We're going to bundle the manufacturing and the installation in one chunk. And Hamilton might do, like Hamilton puts out their tender, OCH puts out their tender, and all. Like the first step is trying to like coalesce that the industry so that we're able to
So I'm gonna high rise. UPVC can be used for high rise. That there is a combustible. There's a code change that is.
The new code change.
Yeah. I know the issue really becomes a question of, are you meeting the structural rating? And you're right. That is something challenging, but it is doable. I personally, we're capable of that, but.
Yeah, I just have a question. So manufacturers have labeled under NFRC and CSA guidelines, and I'm sure you've been involved in a discussion that passive house ratings and NFRC and CSA, they are not equal to each other. And so I'm just trying to understand, if someone's done all their NFRC stuff and CSA stuff, is it just translating that information to say this is what it would perform as a passive house? Because otherwise it seems like only passive house windows are going to get those values.
So I'm trying to keep it, and I'm hoping that I'm not ignoring your question by answering it in this way. Whatever I pop into my energy model,
okay,
the measuring stick that we are having is my energy modeler popping it into EQuest, popping it into E+, or whatever values, like as long as we agree that that is the performance of that window. That is what, so I don't care if it came from NFRC or if we've got the Canadian standard, the US standard, the wherever standard, it is going to be the U values, the solar heat gain coefficients that we that my architects can agree are representative of that product, that they're going to punch into the energy model. So my answer is that I don't care where those come from, but I appreciate that it's because I probably don't understand the industry and the 100% differences in there. But hopefully that simplifies the process on your side of saying, oh, if you just need the U values and solar heat gain, here's how I got them, but here's the performance you should pop in.
Well, the
Dan,
challenge.
oh, and I can jump in a little bit too. Sorry to interrupt. I don't know if you can see me, but anyways, I'm.
Yes,
oh, you
we
can. Okay. I should be mindful. Okay. Well, yeah. Simply, I mean, Dan is absolutely right. In many cases, it's about the standardized performance that you're accustomed to. There will be other situations, notably, I mean, with our work in particular, we are actually getting full certification on all of our buildings. So components don't necessarily need to be certified. But if they're not certified, which means they've not gone through the same testing standards that they're essentially using in German building code, then there is an assessment done. So we've actually done that on the HVAC side. There was a part of, like a major component was critical to our building. We wanted to procure something locally, and they said it was great. They said it could do all these things. We said, well, if it can, just spend a tiny little bit of money and get it tested in an independent lab. That according to the German building code standards that are baked into Passive House, they did, and it was not close. So if it had a pass, it would have been a cheaper option for us. So I think the same thing can exist too for windows. Not everything is going to equate exactly. So in some cases, for sure, you can use the regular standards. In others, like working for Hamilton, it would need to be vetted by a third party if you're not certified. And then I wanted to speak just briefly to a couple of questions earlier. In terms of the procurement, we are trying to make it really easy in Hamilton to work with us. And on the new development side, the way that really works is you're dealing with our construction manager or the design build firm. So you don't have to deal directly with us. And I think at least for these mid-rise and high-rise buildings, that takes care of that issue. I know it's a different piece, some of the grade related units.
So just some context. So I run a third party engineering and energy modeling for Windows. Yeah. And one of the things that we see is a lot of European product will come here promising really good values. And then we'll say, okay, we need to model them to the CSA standard. And they're all very surprised that it performs oftentimes significantly worse than what they thought it was going to be, but it puts them comparable with everyone else. So if it's just the first look at it, it can look like, man, only the Europeans can give us what we want. But when the products are comparable, it's like, no, they're not the same. So that's kind of where protectionism of our own industry I'm looking at, right?
We want to keep this money.
A question is all of this work based on using the European EnerPHit standard, or are you designing some buildings to others North American standards? Where the problem comes in, when you have an EnerPHit design team working in the Passive House paradigm, all of their inputs need to be done the European Passive House way, and there's no way to translate North American numbers that'll make them happy. On the other hand, if you are actually going to be building different projects under different regulatory, other net zero or low energy systems that use North American units, then it'll be the other way around. The European products will have trouble figuring out where their performance is. So the question is this, I know that when Toronto Community Housing was talking about doing this to their whole portfolio, they started, it was all going to be Passive House, EnerPHit. I don't know where they ended up because the committee I was on stopped working. But the question is this going to be driven to European standards, to North American standards, or a mix of both? Because that's going to end up classifying what kind of products you get.
So I will admit we used EnerPHit and Passive House as the introduction. It was the easy, mainly because it is a straight up performance based standard, right? If we talked about a net zero, the Canadian Home Builders Association net zero premise, both for retrofit and for new build, when you dive down into that, what we're actually after is the performance. What is the TEDI? What is the thermal energy density index? What is the overall energy use index, right? So we use those names because they were easily recognizable, but what we were actually after was their TEDI or their EUI. So when we're not going to be like speaking for OCH, we are not planning on certifying these buildings to the NRFIT standard, but we're also not planning on certifying them to the CAGBC's net zero carbon or we just needed to grab a performance measure KPI that everybody was like, okay, I understand what you're trying to do. That's what we did for our first round. And now our architects and our designers that are currently working, they're not like they have NRFIT as that target because they know, okay, well, the NRFIT gave them their 75% energy savings in that building. Now that I'm getting into my schematic design, I'm actually picking equipment. I'm doing that. And therefore, here's the like, I know we were trying to hit 75 and we're getting away with 73. It was just it gave us that first ballpark. We recognize that we're not actually necessarily trying to certify these buildings at all.
But are you still trying to design them to the NRFIT standard uncertified?
Sure.
No, this is really important.
Okay.
It's really important because the whole design team, if it's a European standard, all their inputs need to be in European units. And you can't mix and match easily. And now, I'm not saying if I don't think there's anything wrong with going that way. Just be clear about that, right? Because if it's, or you're going to design it to North American standards, are you going to use North American software? Are you going to use, you know what I mean?
Okay, so maybe if I said it like this, so I'm not sure if you'd like to tell me the North American standard that we should be using.
No, I'm not saying that.
Which one? No, but what would it be?
Like, in other words,
because I'm not sure what
is what you're taking from NRFIT is their approach, or are you taking their methodology and tools as well?
No, oh, sorry. So not their tools, not the methodology and tools. Like we're using eQuest, we're using ePlus,
okay. So then,
in our modeling.
So that's really important for the industry to know, because if you're going to use eQuest and North American tools, then NFRCU factors and North American data is going to be adequate to qualify those products, and they won't have to jump over peculiarly passive house concepts like designing for very high relative heat gain, solar heat gain, high relative humidities. And so they want window frames to have really, really warm surface temperatures that are not required in North America. So these are peculiarities that actually affect product design massively. And if you're working with North American standards, it's going to be much more easy for the industry to ramp up quickly to give you what you want.
Okay, perfect. Thank you.
That's great. And I'll just want to throw one piece in on that. I so appreciate the question. And it is like, we're doing a bit of soul searching about what direction we go. I mean, in Hamilton, we have 9 to the Passive House International, right? So already underway. Our next 10 or 20 are all headed that way too. I mean, if at some point we get so good at it and we have full confidence that folks are designing quality buildings with quality products, we might drop the certification piece. But right now, that's just sort of a backstop for us. So in terms of some of those peculiarities, it is interesting to note that some of them are thermal comfort standards baked into the German building code that have just transferred in. So being able to sit in your window and, the comfort from being able to touch it and the surface temperature, all those things are around comfort rather than energy. And so they translate through the standard. So it's not just on the energy that we're achieving, but it's air quality and comfort. Those are the other pieces baked into Passive House.
And I think just to simplify the thing that I was saying was, if you bring a window that's a European standard, I've particularly modeled, sub 1.9 U value, and you're like, hey, that's where we want to get there or lower. And I modeled to the North American standard, and it's 1.2. So on first view, it seems like the Canadians don't have it together. But then when you realize that they're playing on a different software base with different parameters and different boundary conditions, it's like, wait, it is the same window, right? Like they're not so much better. So that's where my concern or my thought is coming from.
Okay.
So as Sean said, it sounds like you guys are doing some soul searching on the Windows side. I'm going to say this for Fenestration Canada, and Terry, I hope you just reinforce it. We would love to help. This is something that love to be experts and provide some guidance for the process, because it sounds like some of this needs to still be worked out. I feel like we have some very valuable input to that.
Yes, that is literally, I mean, that next steps is that we're going to get ourselves an expert, because obviously we've got to keep the we've got to keep a third party involved, if you will. But then we're going to be engaging the industry, and it is through these presentations that I'm trying to figure out who feels like coming to the table to chat in terms of just helping us figure out what we should be asking for. And then who's going to want to participate in terms of, here's a product that I think you got, here's a pre-qualification for this manufacturer of this window that I think it would meet your needs. So absolutely. That's the goal.
Whatever we can do to help.
The outreach to Daniel and the other community housing groups was totally selfish. We want them buying our members' products.
We want to be.
We don't want products coming in from offshore because they don't think that they can get them here. They can get them here.
And I think you're going to be hurt by doing so. I think you've had that experience.
Lose. If we have to go,
And no offense, there are some great manufacturers in Europe. They do a great job. But once they're here, manufacturing a service problem, like trying to solve service problems on these products are hellish.
Nightmare. It took us 3 months to get the replacement hardware on what we ordered for 1290 COLDREY. Anyways, yes, that I want to be able to drive over to 30 minutes an hour and talk to the actual rep rather than 6-hour difference in a time zone. That's right. How are we doing? Pretty good.
I'm trying to eat up.
Well, sorry, but anyways, we're
nothing else for Daniel or Sean?
Yeah.
All right. Thank you very much.
Thank you so much, Sean.
Thanks, folks. This is awesome.
Take care.
About 5 minutes, we'll have our next session with
That's
Robert Jutras.
All right. And I'm sticking around.